in my last video called Electronic Equipment Repair, I was attempting to fix a couple recording monitors that I have, and they're KRKs. And I was thinking, I have it apart here. I'll turn around so you can see the front. So there are these little base reflex monitors, and they're pretty awesome, except they do have a problem. And so the tweeter was buzzing really loud and nonstop. When I'd had them stored for several years. I've hardly even used these things. And so I pulled them out the other day, and I had plastic garbage bags over them to keep them, make sure they stay dry. And this one got wet. It's got a rusty screw here. When I saw that, I thought, oh, that's not good. So I got them out. I hooked them up, turned them on, and they made noise. Both of them made noise. I have a pair of them. And just for a couple seconds, and the noise went away, and they were great. They sounded great. And they're not bad sounding. So after a few days, this tweeter started buzzing, and nonstop. As soon as I turned it on, just nonstop buzzing. So, and it turns out it was a tweeter. In my last video, right when I shut the equipment down, the camera down, I turned the speaker around, and I happened to notice it was the tweeter that was buzzing. So I was assuming, originally, when I started working on fixing this, I was assuming that it was a bad solder joint on one of the electrolytic capacitors, because they tend to have a problem with galvanic corrosion. Two big electrolytic capacitors here, and then two smaller ones back inside. And like I was saying in my other video, that you have to be real careful with some electronic equipment. It can kill you even when it's not plugged into the wall. And the reason for that is capacitors are like batteries, and they will hold a charge. And depending on how big the capacitor is, its voltage rating. Like these ones here, I believe they're 50 volts. And DC current can be fatal at 50 volts. It would be pretty unlikely, but it's possible. Bigger capacitors can be deadly for sure. And so what you want to do, if you're working on electronic equipment, which if you don't know what you're doing, I don't suggest that you try, is that you need to discharge the capacitors. So this has been sitting all week, so I'm sure they're probably okay, but just to be on the safe side, what you do is these capacitors, they have two leads that solder onto the board. So the component side of the board is here. This is where the capacitors are. And then the other side is the foil side of the board, the circuit side, and that's where the solder is. That's where it's soldered. So what you need to do is those two pins coming out of the capacitor, you need to short them out, and that'll discharge the capacitor. You want to hold on to something insulated like the handle here. You don't want to be touching metal. And you definitely don't want... the worst thing you can do is get shocked with one hand while holding on to something that's grounded with the other, because what happens is the current goes up this arm, and it's seeking ground. That's where it wants to go. And so what happens is it goes up this arm, and it starts heading for this arm. That's because you're holding on to something grounded, like, let's say, a faucet or something like that. And the path to ground is where your heart happens to be. If you're grabbing on with one hand and grounded with the other, if you get shocked with one hand, your heart is in the path to ground. So that's what'll stop your heart. So you got to be really careful. Old TV sets before flat screen TVs are real dangerous. And then any kind of power amp or anything that has big capacitors are extremely dangerous. A friend of mine had a Vox bass amp for his bass guitar. It was big. It was old. It was, I think, like 1965. vintage amplifier and cabinet. It was all in one unit. And it wasn't working. And so usually, and I've fixed several pieces of equipment, electronic equipment, and usually what I find is that you get galvanic corrosion with the leads. Let me short these out just to be on the safe side. I'm sitting there touching over there. I'm sure they're okay though, because it's been sitting. And but even if it's been sitting, you never know. So you want to just be extra careful. So I'm just shortening them out. Okay, so at any rate, this kid brought out his bass amp out to the research farm where I used to work and live, and he asked me, "Can you fix this?" And so what usually happens a lot of times is galvanic corrosion happens because of because these capacitors, like batteries, they hold a charge. And so when you have dissimilar metals, what will happen is that there's a more noble metal and a less noble metal. And so depending on the type of metal, and you can go online and find a galvanic chart on metal nobility, and you can see what metals are more noble and which ones are less noble. And so what happens is that if you take, like for instance, a boat has a boat prop and boat shaft and rudder post, and let's say the rudder post might be stainless steel and the prop might be bronze, and like my boat, it's got a bronze prop, but it's got a stainless steel shaft. And because of the two different metals, what happens is that because it's in salt water, current, it actually acts as a battery. When you put two dissimilar metals in salt water close together but not touching, it's like a battery. And so what happens is current will flow between those two metals if they're dissimilar metals. And my other boat I had, my other sailboat, I had installed an engine in it, and it was in the water. The boat was in the water, and the prop shaft was in the boat, and the prop was on the prop. But the transmission I had not connected yet to the prop shaft, so it was just the prop shaft in the water coming up through the hull of the boat and into the boat. It was a 9-foot long bronze prop shaft with a bronze prop. And so I got this idea while I had this all apart. I was thinking, I wonder if there's a voltage going across between the prop shaft and something that's grounded, like the engine block. And so I took my voltmeter and I put one lead onto the prop shaft and the other one onto the engine block. And I measured 0.5 volt. So there you go, that's a battery. So what happens is current flows from one metal to the other, and as it does, the least noble metal will decay. And so what happens is that when the current is flowing, electrical current is flowing between those two metals, it's actually removing atoms from the least noble metal and putting them into the more noble metal. And so the least noble metal will corrode and decay. It'll just literally obliterate. It'll just, over time, it'll just shrink and get pitted and less to where it will be gone. And so that's why they use sacrificial zincs on prop shafts and boats, and like steel hull boats, they have big zincs that to put along the hull under the water in certain places, and that protects the steel hull from decay. So the same thing happens with electrolytic capacitors because you're dealing with different metals. There's the solder that has, usually it's like tin and lead, and then the foil on the board is a little different metal, and the pins on the capacitors are a little different. So you're dealing with different metals. And so what happens a lot of times is that the solder joint, the solder itself will actually corrode. And I can, on some of the equipment I've worked, I could actually see the corrosion and use a magnifying glass. And where the pin goes through the solder, and it's soldered, what happens is that corrosion, you'll see this little black ring around the pin in the solder. And if you, like with these capacitors, if you push on the capacitor, and you push on the capacitor like this way, and the solder joint's over here on this side, if it's corroded, it can actually be totally detached from the board now. And so when you push on the capacitor, you can see the pin on the capacitor move in and out of the circuit board. So that means it's not soldered anymore. It's corroded. So how you deal with that is you just you heat up the solder joint. You can remove the solder if you want, or just heat up the solder joint and then resolder it, and then that'll fix it. So I did that in the last video, and it didn't fix it, so it wasn't that. I also looked at I didn't mention this in the last video, but the capacitors. Let me see if I got a board here that's got a small capacitor. It'd be easier to show. All right, here's a little circuit board from a coffee brewing equipment from where I work. And this is an old board that's been discarded. And I was going to save these capacitors in case I needed them in here, but I don't think I do. So what happens is the top of this is the capacitor here. And so what happens is a lot of times when these capacitors go bad, they also swell up. And a lot of times the top here will puff up. So the cap will puff up. Instead of being flat, it'll puff up like that. Well, none of the capacitors in here are doing that. So I think the capacitors are fine. And I don't think there's any corrosion in the solder joints on the capacitors now, but I still have a buzzing sound. So I did some research about these monitors and found out something interesting. This is, I think, generation 2 of this company's monitors that they made. So I'm pretty sure it's Gen 2. So it's generation 2, I'm pretty sure. And they did something strange. They coated the, turn it this way, and you probably may not be able to see it, but they coated the boards on the component side with they sprayed it with some kind of goop kind of stuff. Now, I know that there's this stuff that you can spray on circuit boards, and circuit boards that are going to be exposed to moisture. It's called BoShield. And Boeing and NASA uses that stuff on circuit boards to protect them from moisture. And I don't think this is BoShield, but they sprayed some of this stuff, and it's kind of a dark color, kind of a blackish type of color. And I've noticed that it's crystallized. So over time it is crystallized. And I don't know if they sprayed it on here. I don't think they sprayed it to protect it from moisture. I think what they did is they sprayed it on here to protect the components from vibration, because this is a speaker and it's pretty loud and it creates vibration. So that might have been why they sprayed this stuff on here. I found out that what happens over time with that stuff is that it looks to me like it crystallizes and then it becomes conductive. And so it starts shortening. It shorts it shorts out the board, okay? And certain places on the board might get shorted out. So what I'm going to do is I'm going to take these boards apart and remove them completely out of here. And then I'm going to try to clean them. And so I may just try rubbing alcohol a little bit in the area and see if that does it. But because the components and the capacitors are kind of down on the board, I may just go ahead and try washing them. And believe it or not, you can put circuit boards in the dishwasher. I don't really recommend that because solder's got lead in it, and I don't know if you want lead on your dishes. But I've heard of people doing that. Now, it depends on what's on the circuit boards. Certain things on the circuit boards, you would not want to get it wet. Like, for instance, transformers, any inductors like that, anything like relays that are moving parts. Relays are like solenoid switches that are electromagnetic switches. And that wouldn't be good to get those wet. But most components on electronic boards can get wet as long as there's no electricity applied to the board. And make sure the capacitors are discharged, because that can also damage components. If there's a charge in the capacitors and you get it wet, it might discharge and go into one of the other components and damage it. So what I may try to do is I'm going to maybe just drench this in alcohol and see if that rinses the stuff off. And then if that don't, then I may just take the hose out here and spray it with the hose with high pressure water and see if I can get it to wash off, and then make sure it's really, really dry before I put it back together. Maybe use a I have a little electric hair dryer that I like to use for drying out stuff. And so I'll just have to make sure it's really dry before I put it back together and plug it in. So that's what I'm going to try now. And so I got some wires I have to disconnect from the speakers here to get the board loose, and then I'm going to look and see what I need to do to take it apart. So both these speakers are, when you first turn them on, make noise for just a few seconds, and then, like I said, this one, the tweeter keeps buzzing. So I'm going to start with this one first and see if I get success with it, and if I can fix it, then I'll go ahead and take the other one apart and clean all the guck off of that board too. It just makes noise when it first comes on, but this tweeter doesn't buzz on the other one. So at any rate, I'm going to go ahead now and start trying to tear this apart. So there it is. So there's 4 capacitors. You can see the 2 taller ones in the back, and then 2 shorter ones are kind of next to each other in the middle. Those are the main electrolytic capacitors. And so I'm going to finish that story about the base amp here before I go any farther. So this kid brought out an old Vox base amp and cabinets. The amp was built into the cabinet. Vox is the old guitar and bass amplifiers that they built in England. So the Beatles used to use them. And so they've been around a long time. And the one he had was old. It was probably like, I'd say 1960s, 65, I think is what it was. So it wasn't working. It wasn't turning on. No power. He wondered if I could fix it. I said, yeah, bring it on out. So he brought it out to the research farm. And what I did was, just to be on the safe side, I laid down a great big piece of cardboard on the cement floor inside the shop. We had a shop that, it was a shop that we worked on farm equipment because Research Farm is farming. And then we also did our lab work in that building as well. And so I set up this big sheet of cardboard on the floor so I wouldn't be grounded. And then I took the screws out of the cabinet to take it apart. And I got it apart. Now, the bigger the capacitor, the more dangerous it is. And it had capacitors in there about the size of this Ocean Spray cranberry sauce can. And you see stuff like that, you just be aware. You can wake up dead, okay? So you see it, you better not be messing with it unless you know what you're doing. So capacitors will have 2 wires coming out. And so what I did was I saw these big capacitors in there. There's one, especially one huge one this big. And what I did was I put on rubber boots that I used on the farm. I put on welding gloves. And I got a huge Sears Craftsman flathead screwdriver, and it was a lot bigger than this one. I mean, huge. It was big. And I very carefully shorted out the 2 leads on the capacitor. And as soon as I touched it, it exploded. It's like, boom! And it literally melted the end of the screwdriver so bad that screwdriver was worthless. I literally had to take it over to the grinder and grind it flat again so we could use it. And yeah, if I had touched that, I wouldn't be here right now. And that amp hadn't been plugged in a while. He had tried it before and it wasn't working, so he unplugged it. And I asked him, I go, when was the last time you plugged it in? He goes, it's been a while. I can't remember how long it was, but you know, we didn't plug it right in as soon as we got it to the shop. And yeah, that's was a real eye opener. I was ready for it though, because I've done this stuff before. I used to play around with capacitors. It was just not real smart. I'd charge them up. I had this one capacitor. It was pretty big. It's probably about the size of the screwdriver handle. And I'd charge it up, and then I'd take the 2 leads and I'd touch them together, and it makes big sparks. And that capacitor could have killed me. But you know, you're a kid. You're just kind of young and dumb. So, at any rate, okay, at this point now, I got this out. So I'm just going to have to clean it up. So I'll see what I can do. I think I'll get some rubbing alcohol out right now and see if the rubbing alcohol will take some of this off. I think I'll start on the edge of one of these big capacitors. There's some this goopy stuff right here. See if it'll wipe off. I don't know. I may take this down and steam clean it at the car wash. Looks like it might be breaking it down, but I'm not really getting anything coming off the Q-tip. I built some midfield monitors, and I recessed it was two woofers with a horn in the middle. And when I built the cabinet, I have a notch in the center where the horn goes. So the horn sits, so if we're sitting sideways and the speakers go this way, the two woofers go this way, the horn's in the middle. I recessed the horn into the cabinet as far back as I could get it. And the reason for that is high frequencies travel through air faster than low frequencies. And I studied recording engineering. I've been in a few really nice recording studios. And when I was at the time, there's these monitors are called URI time-aligned monitors. And they were big, huge woofers, and they had a horn built into the center of the woofer. So the horn actually moved. And then they delayed the sound coming out of the horn, the high frequencies. So they had a delay circuit to delay it, and it's adjustable. And they would delay that horn, the high frequencies, and adjust it to where, because high frequencies travel faster through the air than low frequencies do, they delay it. So when the sound comes out of the monitors and the engineer sitting at the mixing console, they adjust it for right where he's sitting. And so what happens is that the low frequencies, the high frequencies hit him at the same time. And so they're called time-aligned monitors. So I come up with this idea, instead of delaying the horn, which a delay circuit would actually degrade the sound a little bit, degrade it. I thought, what if you put the horn farther back in the cabinet and physically make it farther back? So, of course, you can't adjust it without the delay circuit, but I kind of guesstimated, okay, these are mid-range or mid-field monitors, which means they're not real far away from you and they're not real close like these are near field, but they're in the middle. So they're, from the engineer, probably a good 10, 12 feet away. And so I thought, okay, I'll go ahead and try this. And I did this. I built these cabinets back in, it was probably around 1992. I had my own little recording studio, and when I saw these URI time-aligned monitors, I started thinking about it, and I come up with this idea. I thought, that's great. So I got some JBL drivers, and I built the cabinets myself. I designed them myself. I used the Greek golden rectangle formula for the cabinets, which I wished I hadn't. Because I originally was going to make them skinny and deeper, but if you notice, speakers are mostly the same rectangle shape, and that's the Greek golden rectangle. So it's weird. If you get this formula right on building a cabinet with the right dimensions, the speakers actually sound a lot better. And that's why the Parthenon in Greece has this sound so good. That's a golden rectangle. And so I decided, well, I'm building these things. I want to make them as good as possible. So I used the golden rectangle. And originally I wasn't going to use the rectangle. It was going to be more square, more of a cube shape. And I originally wanted to use acoustic suspension speakers, which means that they're airtight. But the drivers I bought, they were JBL drivers, they were on sale and I got a good deal, and they were bass reflex. And so they needed to be ported, which means that you have holes in the cabinet so air can get in. So what happens is the speaker moves back and forth, and the air inside the cabinet goes through these ports. So they're holes with tubes. Sometimes it's just one tube or two tubes, and the tubes have to be the right diameter and the right length to work properly. That's kind of like a Bose wave radio. That's why these little radios now have such a good low end on them. And it's bass reflex. So I went ahead and used a great rectangle shape of the cabinets, which means they're wider. So they're about this wide, they're about, let's say, about 3 feet tall. And they're only about this deep, probably about 10 inches. And so I went ahead and built them, and I hooked them up, and I was just blown away how good they sound. I haven't heard monitors sound like that. The only place I've heard monitors sound that good is in a recording studio, and so I have them here on the boat, and they're awesome. I love them. But so I built these, designed them in '92, and built them in '92, and I covered them with black Formica. They look really good. And a few years ago, I just happened to be online, and I was looking at monitors, and they were JBL monitors, not just the speakers, but cabinets too. And damn if they did not design cabinets exactly what I came up with in 1992. Don't ask me how it happened. I was the only person that had these. As far as I know, I've not ever seen any other speaker cabinets like this in the world. But they built them like I originally wanted to build these. They didn't use the rectangle, like the golden rectangle. They used the more cube shape. So the speakers were skinnier, which I wished I had done, because if I made them skinnier, they would have fit in the boat better, because I have this model ship of the USS Constitution, an old sailing ship. It's about this big, and it sits in between the monitors, and it's all the room I have. And I wished I had more. I could spread the monitors out farther, and it'd give more room for that ship, so you could see around the backside, the transom of the USS Constitution. If you've ever seen it, it's got all these windows in it, and it's just beautiful. But you can't really see the transom on this model that I built. And I started building this model when I was 15, and it's still not done. And I got the standing rigging on it, and all I got to do is finish it with the running rigging, and it'll be all finished. But I got a lot of work to do on this boat first. I want to get done, and then eventually one of these days I'll maybe get back to it and get it all finished. It's a miracle that thing survived. It's so fragile all these years. Okay, here's the monitor. Here's the recording monitors that I built. So this is one of them. And I don't have them ported. I have the holes drilled in for the ports, so for the bass reflex. And I don't have the tubes installed. And the reason for that is because when I put those tubes in, the low frequency is going to be boosted, and I don't want to blast everybody out of the marina. So I'm leaving them out for now. When I put them in, yeah, it'll boost the low frequencies up, and it'll really thump. And it thumps a lot without the tubes in it. So, at any rate, there they are. You can see the horn is recessed in the cabinet. So this is the design that I designed. I I built them back in, I think it was 1992. And I still just got to get the tubes in and then finish the trim. I put gold leaf on the bottom cabinet, on just above the bottom woofer. So that's gold leaf, and it looks really cool when I turn on. I have different color LEDs in here, and when I turn on the red ones especially, it looks like a laser beam going around. So when I get all the trim around the edges with gold leaf, they'll just glow. So that'll look really cool. And but there they are, two 8-inch JBL drivers and a horn. So it also has that little dial. There's a rheostat, and that's for adjusting the volume of the horn. So I can adjust that separate for the high frequencies. So you can see the horn is recessed in, and the reason for that is because high frequencies travel through air faster than low frequencies, and when they hit where I'm sitting, when I'm mixing, the the high frequencies, low frequencies hit me at the same time. So, and it's amazing. I've had people sitting in here, we'd be watching a movie or something, and they ask me, "Do you have surround sound?" And it's like, no. But like Back to the Future, the original, the first movie, when they're standing in the parking lot at the mall, and he's driving the DeLorean with a remote control towards them. When the DeLorean goes past them, when you're sitting in here, the sound goes right past you, like the car just went right through you. It's really bizarre, and I think a lot of that's just the room acoustics in here in the boat. But at any rate, I love them, and I just need to get them finished. It's a lot of my projects take me forever to get them done. So, but yeah, they're awesome. I love them. Just wished I would have made them skinnier and deeper, and then I could have put them farther apart from my model ship here that I have that I need to get finished as well. And I got to finish this whole area, and the boat needs to be done. I tore out some cabinets here to put this stuff in. So, and so that's it with these. Tomorrow, I'll go ahead and continue on with this and see if I can get this sucker fixed. And hopefully I can. So, anyway, have a good evening, and I'll see you tomorrow. One good thing, this is rubbing alcohol, so it should dry pretty fast. Okay, I think that's good enough. So yeah, I can see now I was right about this being the bridge rectifier. So there's 4 large germanium diodes. So that's the bridge rectifier, and you connect them up kind of in it's like a diamond shape, and then you connect off each one. The diodes only let current flow in one direction, and so what it does is it takes an alternating current. It goes like this is 0, your ground reference, and then because you're spinning magnets like in a generator, like at the dam, or in your wind turbines and car alternators, except they're electromagnets. They're not actual magnets, but so you can use electromagnets or real magnets to generate electricity. So it ends up being an alternating current where it goes. It's like a sine wave, so it goes above the ground reference, and then it goes below the ground reference. So this is like the negative side, and then the positive side, and the negative side. And what the bridge rectifier does is it puts it reverses the negative side and flips it up to the positive side. So now you just got like humps going on the positive side above the ground reference. These 2 big electrolytic capacitors here, what they do is they charge up and they discharge, and you have to have them at ones that charge and discharge at a certain rate. And so what they do is that they take the humps out of the current. So what happens is that now you have instead of these humps on the positive side, the bridge rectifier flipped everything up to the top. So it's all positive humps, but they're humps. They're not flat. So it's not pure DC. And so what these electrolytic capacitors do, they charge up on the high part of the hump, and then they discharge when the hump starts to go down. They discharge and they put current back into the system. So basically what happens is it smooths it out, creates a more smooth DC current. So that's what it does, is it's converting AC to DC. That's what these 2 big capacitors are for. These other 2 capacitors are part of the audio circuit, and that's what those are for. So one's probably for the amplifier for the woofer, the low frequency, and one's probably also for the amplifier, because there's 2 amplifiers on here. That's what this heat sink's for, to cool down those amplifiers. I can see them right here, and so that's what those are probably for. So now I think it's I hope it's dry enough, and I'm going to go ahead and hook it all back up and plug it in and see if the buzzing stopped on the tweeter, and then hopefully the speaker will work as well. And then the black wire, which is not cooperating right now. It's not wanting to go where I want it. Okay, I have to do this one by feel as well. Okay, everything's plugged in. Okay, it's set to 110. The power's off. I'm going to set it to 0 dB. And it's both levels, high frequency and overall volume levels, are set to 0 dB. Now I'm going to plug it in. I'm going to double check, make sure nothing's touching that shouldn't be touching, because I have this transformer here. I think we're good and clear. Okay, here we go. And we'll see if this thing's going to buzz or not. If it doesn't buzz, I probably will have it. And the only thing else I'll have to do is hook it up and play some music through it and see what happens. But I'm pretty sure if it's not buzzing, it should be okay. Okay, here we go. Hopefully it'll stop. I have a feeling it'll probably still buzz, but let's see. Maybe not. Buzzing. Oh well, so that didn't do it. I don't know. And I don't think it's the capacitors now. So let me just go ahead and plug it in, try this again, and then I'm going to hook the tweeter up and try it again. Wow. It's almost completely silent. I can hear it. Okay, let's see what the tweeter sounds like. It's going to buzz louder probably, but I think it's definitely quieter than it was. So, unplug these. And plug the tweeter back in. Okay, so I got the tweeter connected. And let's see if it's quieter. If it's quieter, that means I'm on the right path. So it's not making any sound. Whoa. Okay, let me look. Something, I can't believe it. It's not making any sound at all now. Is the logo light on? Yeah, the logo light's on. Okay, let me see if I can get a signal in here. Wow, that's interesting. It's not making any sound at all. Buzz totally stopped. So I'm going to go ahead and hook the woofer up and see what happens. Okay, now the woofer's hooked up. Okay, let's see what happens now. The tweeter stopped buzzing. I'm hearing a little bit of buzzing through the woofer. The tweeter's totally stopped buzzing. Interesting. So let me see if I can run a signal over here and run some sound through it. Okay, so I'm going to turn the volume level all the way down, and I'm going to go ahead and turn the power on. Power's on. Wow, it's even quieter. So let me turn up the volume and see if it works. Well, that's weird. Okay, let me see what's going on here. It's not very loud. Okay, I got a problem now. So the tweeter's working. And the tweeter's not buzzing at all. Go figure. Let me double check. Yep. But the woofer's not working now. Okay. Okay, I'm going to untwist this cable. It's twisted. And it might be shorting out. And turn it on. It's working now. All right. Let's hook up the tweeter. That side. So I don't know how that sounded through this microphone here. Probably not that great, but it's working. Success. Now,
attention retirees, if you're willing to be a
commercial. It's YouTube. Let me turn this off. Okay, now the trick is putting this all back together, and will it still work? So I'm going to try that next. See what happens. Let's see if I can get this together. Wow. Well, that's cool. That means I can use them now if it works when I get it back together. Something was shorting out. I think it was this cable was twisted. It might have a short in it, which may end up being a problem. So I may have, it's a ribbon cable. I'll have to replace it. If it's a wire shorting out, it'll probably end up having a problem in the future. Well, this ain't good at all. I don't believe this. No, it's not working at all. Yeah, it's got major problems here. I can't believe this. Something's shorting out real bad. The logo light's on. That's so strange. Why would it just totally stop? So, okay, that's it. I'm done with it for tonight. I ain't fucking with it. I gotta cook dinner.
Producers, if you struggle finding sounds and samples that work for you, then you have to check out this plugin. It's called Arcade, and it's my #1 go-to for building tracks. What I love about Arcade is that it's a sample library and a playable instrument all in one. If you go over here to where it says search, you can load a sampler, play an instrument, or find a sample. There are so many individual samples, and you can search them by type too. Next, I want to show you the sampler. I love using this to build drums. You can play them individually or together. You can adjust the pitch, time, and so much more. Lastly, I want to show you instruments. I really like this honey kit, so let me show you what it sounds like. I love using the macros and the tweak options because I can quickly change the instrument to make it sound unique. This will change the way you make music. So don't wait and download Arcade free today.
Go figure. You got to unplug the plug to get this last screw in. I don't believe this. Go figure. Yeah, it's a short. That could have been. There could have been like a ground fault interrupt built into this thing. I don't have one over there, but the light was on. That didn't make sense. I think it's just short. I think there's a short in here. And so I don't know how long it'll last, but it's working now. So I'm going to go ahead and try this one more time. Okay, I unplugged it. I'm going to unplug the sound source. I'm going to unplug the power supply. The power's off. I'm going to turn all the knobs to 0. I'm going to plug it back in. Power on, power in, signal in, power on, and the song's over. That's not. There we go. Okay, well, I lucked out again. I usually luck out on this stuff, but unfortunately, I know what's causing it. It's definitely got a short, I think was the main thing. The buzzing was really weird, but it's gone now. It doesn't buzz at all. Matter of fact, I'm going to turn it on. I want to see if that woofer evacuates. Let's see what happens. No. Okay. So the other speaker I have, it's not even making noise now. I mean, it was making noise when I first turned it on, just for a couple seconds. Now it's not even making noise, and so that's really good. The buzzing's gone. The speaker didn't evacuate. The other one does. When I turn it on, it sucks in, and it goes, and then it releases, and then the noise goes away, and then it works fine. So I'm not going to mess with that one for now. I'm just going to live with it. I'm going to just live with it and see maybe if it'll fix itself over time being used. These things haven't been used. I mean, I've probably only had like maybe 5 hours of music played through these when I first bought them, and then I put them away because living on the boat, I just didn't. I didn't have a place to really. I needed to. I have places I want to put them. There's a couple places I can put these in here, but I wasn't ready for them yet, and now I am. So, yeah. So, if you found this video helpful or entertaining, at least entertaining, give me that, please. Please like and subscribe.